Welcome everyone. Let me talk about how we were tuning Drupal on Google Cloud Platform. First of all, let me introduce myself. My name is Miro Michalička. Uh, I'm DevOps engineer at Jobiqo since January of this year, and I'm located in Bratislava. Before I was doing DevOps at Jobiqo, I was doing Drupal development, so that's quite important when you are working for company whose main product is built on Drupal. Now let me talk you something a little bit about Jobiqo. So we are building job boards for our customers. So we are not running these job boards, and we have currently two products, Jobiqo 7 and Jobiqo 8. Both are doing or are aiming to do the same thing, do the job board. And but Jobiqo 7 is built on Drupal 7 and Jobiqo 8 is built on Drupal 8. Drupal is CMS, it's PHP-based CMS. So how our current hosting situation looks like. As I said, we have PHP-based application, so we are simply using a server by Hetzner. We have Nginx. On the same box, we have PHP, FPM, and we have single MySQL server, but each of the sites on the server has separate database. We also have Redis for caching and Solar server for searching. There are separate cores for every site on Solar server. Sometimes we might put Cloudflare in front of the Nginx, so the anonymous requests, which are the same for every customer on the site, get cached and don't make load on the server. So if you are looking on this, then you say, okay, that's quite easy. But if you look on this, and then this, it's not so easy to run that anymore. We are lucky that we are doing just DevOps part and not also the administration part. We have separate company for that. We are currently running 40 servers, and it was getting pretty hard to administrate that. We are running different number of sites on every server. On some servers, it might be just one site. On another servers, it might be up to 3-4 sites. And although this environment is the same on every server, we might have some special requirements like different version of Solar, and that would be better to do somewhere else. Here comes solution, which is cloud, and thanks to expertise from Russmedia, we decided to do our proof of concept on Google Cloud Platform. We built this proof of concept together with Philip, and we were using Terraform and Helm, and it was all deployed on the Google Kubernetes engine. This is our first solution, which we built. So inside of the Kubernetes engine, we have single node pool, and in this node pool, we have two nodes. In every node, there are 3 pods with the application, 3 pods with Redis, and I think there are also, the application is, of course, the Nginx and the PHP, so it's not 1 columnar, but it should be 2. And then as ingress, we were using Nginx, I think, and for the database part, we decided to use CloudSQL. The CloudSQL is a managed service by Google, so we didn't want to maintain another part of the application, so that was a good decision for us.
And as the storage, we decided to use GKE persistent volume. First performance testing showed that on Hetzner, which is our current provider, page load, including all assets, took around half a second. But on GCP, it took almost over 3 times more, 1.6 seconds. So after that, we made some changes in the application and we wanted to deploy, but then we found out that GKE persistent volume type of volume has only single, is able to read and write from the single pod only. So the next step, 1.5 version, was to add another node pool with cluster FS in it. That helped quite a bit because whole page load went down to one second, and on Hetzner it was around half second. So on GCP it was twice more, and the document page load, so only the PHP part took almost 400 milliseconds on GCP and around 50 milliseconds on Hetzner. After this, we started tuning Google Cloud SQL a little bit, but we weren't able to configure all parameters we wanted to do. So we started thinking what to do about that. The basic requirement was to have high availability setup. So we needed to have 2 node pools. And therefore, we decided to put MySQL into node next to the application. This setup gave us speed very close to the Hetzner speed, but soon we found out that I misconfigured the MySQL pod, and there was no persistent volume, so MySQL was writing everything to some temporary storage or directly to memory, and that was the reason for this speed. We didn't know that at this point, but we focused on these numbers because we thought that, okay, it's possible to do that. And we started just trying different things because this wasn't high availability setup because we only had 1 pod of MySQL in each node. We decided to try MySQL high availability Helm chart, but it was more joke because we weren't even able to load that. This MySQL HA Helm chart is master slave replica, so there shouldn't be any latency. So we were a bit surprised. And as the next step, we went directly to Galera. If you don't know what Galera is, it's MySQL master replication. It's based on MariaDB, I think, but it shouldn't make big difference. And yeah, the speed was around 500 milliseconds for time to first bit on GCP, and on Hetzner we were about 300 milliseconds. If you notice, I started measuring times a bit different here. We started measuring time to first byte and content download. And if you compare the content download, it's quite higher on GCP. And we were wondering why is this? Because the speed, okay, but the content download, it was just too high. So at this point, we engaged, or Philip engaged, our partners from Cloud Pilot, and they consulted with Google. We went on a couple of calls with Google consultant, and he recommended two things. One thing was to try profiling with Istio to find out if there is any hidden latency in network, but that didn't help because, of course, there wasn't any hidden latency. And then the other thing, he recommended something called Vitess.io, and about Vitess, Philip will talk more about tomorrow. So his recommendation didn't really help, but he reassured us that we made good step when we ditched CloudSQL, because he said that CloudSQL optimal performance is at 2 terabytes of data, and well, our databases are usually around 10 gigabytes, 20 gigabytes. So yeah, the Galera should be performing much better. We decided to test different configuration of Galera, so we removed the replication part of it, just to see if there might be any latency between the Galera replication, and that might be causing slowness with the application. But as you can see on these numbers, time to first byte went even higher, but the content download went lower. At the fifth version, and I think this is the last version we tried, we changed one more thing, and it actually helped. In the previous versions, the application and Galera were communicating via short service name. So if you deploy your Helm chart, then you will have something like Galera or MySQL, and you are able to access that within the same node. But we changed this to the full service name, and it actually helped. So it brought content download down to 50 milliseconds. Now we wanted to do something with the time to first byte, which was still around twice as much as on Hetzner. And we decided to do some profiling. If you know PHP, then there is inbuilt solution for profiling PHP. It's called XHproof, but then you still need some tool to visualize that or somehow analyze that. So we decided to use a trial of New Relic, and there is huge advantage of New Relic compared to some other tools that you can see inside of your Drupal application. So we were able to see specific Drupal functions, Drupal hooks, which are being called, and might have some effect on the speed of the application. But this is list of the top performance issues we were able to get. And you can see that from these, I think, 10 issues, the 5, so the half, is something to do with cache. And Drupal is very database heavy. So just selecting from the cache table in the database was taking 130 milliseconds on every single request. So we would be able to offload this caching to the Redis, but we were still comparing the same configuration as we had on Hetzner for this case. So but it's just showing that Drupal is really database heavy. As the last step, we decided to do some light tuning. The calls with the Google guy told us that there is correlation between the volume size and the bandwidth. In the previous iterations, we were trying just with 10 gigabytes because we didn't have a lot of data. But now we decided to use half a terabyte. And we also upgraded the VM type. So before we were using E2 standard 2 instances for our nodes. And now we upgraded that to C2 standard 4. And this is the last iteration we did. And within the company, we decided that these numbers are acceptable. They are around about 1/3 higher than on Hetzner. But I think that it's understandable because it's cloud compared to the dedicated server. So there must be some degradation in performance. In the end, let me sum up lessons learned. I think the infrastructure as a code is awesome because right now although we are doing deployments using Puppet and Ansible, Terraform is completely different level. It also helped me that I knew about close integration of New Relic and Drupal, so I was able to pick the correct profiler. And in the end, I would say that you need to have a realistic expectations because we went to this project that we want to have exact same times, and just because of the different architecture, I think it's not possible to have exactly same times. Now, the next steps for us. We want to do one more thing. We want to test our Helm charts and our Docker containers on the Kubernetes cluster, which is not on GCP. We have deal with my friend who has Kubernetes cluster on physical servers, so we want to test the performance there. And then the next important step is to find the right customer willing to pay for GCP because the base solution is around 6 times more than what would we pay on the Hetzner for the comparable hosting. Thank you for your attention. And